Hey, I'm Courtney Waterman, your tutor. Lover of anime, manga, and math. And you just tuned into another session of Tutor Me Sempai. Welcome back, everyone. Today we're jumping into an 11th grade topic, dividing complex numbers. Now, if you're new to my channel, I'll be putting time codes in for this video in the description box below, so use that to skip ahead to whatever part of the video you think is most interesting. As always, if you have any questions about what you see today, or even your own homework, you can always put in the comment box below, or visit my Facebook page at Tutor Me Sempai and tell me all about it there. At the end of this video, I'll be linking my 11th grade playlist in which I cover a lot more topics, so if you're interested in that, make sure you stay tuned. This video is going to have two parts, so leave a like, smash subscribe, and let's get started. So when dividing complex numbers, we want to focus on two things. The very first thing is we want to remove all imaginary numbers from our denominator. The second thing is we want to make sure our result looks like a complex number. Now that might seem kind of obvious, but you'll see what I'm talking about when we focus on our example in the next part. However, our final result should look like a complex number. That means we need to have a real part plus an imaginary part. Our components need to look like that. If our answer does not look like that, we haven't quite finished our problem here. So we're going to focus on that, like I said, in our next part of this video. But for right now, let's focus on that first part. How do we get rid of all the imaginary numbers from our denominator? Well, in order to do that, we need to focus on something called the complex conjugate. Now, what is a complex conjugate? Well, assuming you have a complex number that looks like 2 plus 7i. Its complex conjugate is going to look exactly like this, except for one small change. You still have that 2 and you still have the 7i, but instead of having a plus here, you're going to swap the sign. It's going to be the opposite sign of whatever you have here. So if this was 2 minus 7i, it's going to be 2 plus 7i. And it doesn't matter what your complex number looks like. We can have a complex number like this, a rather simple one. Let's say we have 1 plus I. Its complex conjugate is going to be 1 minus I. Let's say we have 25 plus 89i. Its complex conjugate is going to be 25 minus 89i. All you're doing is alternating the sign. You pretty much have the same exact thing, you just have to do the opposite sign here. And these are going to be your complex conjugates. But how is a complex conjugate going to help us remove our imaginary numbers from our denominator? Well, let's say we have this 1 plus I and its conjugate, or its complex conjugate, 1 minus I. When you multiply these two things together, what do you get? Well, if you don't know how to do this, or you haven't seen my previous video on multiplying complex numbers, you can find it right up here. However, this is going to be a rather simple one. This is going to be 1 minus I plus I minus I squared. Once again, if this confuses you, check out that video. But we're going to simplify this. Notice it goes from 1, we have minus I plus I, those cancel out, minus I squared. Well, what is I squared? Well, this is going to be 1 minus I squared is a negative 1. So minus a negative means that we have 1 plus 1, which gives us what? 2. So by multiplying our complex conjugate by our original complex number, we canceled out the middles and we simplified our last I, resulting in only a real number being left over. And this is always going to happen when you multiply a complex number by its complex conjugate. You're always going to cancel out the middle part and your i's will fall out because you're going to have to simplify that I squared there. So if you do all your math correctly, there should be no more imaginary numbers and you're left with your real numbers. So now that we've talked about complex conjugates, let's put this to use by tackling our example for today. In our example for today, we have 4 plus 2i divided by 5 minus 3i. And once again, there's two things we want to focus on. First, we want to get rid of all of our imaginary numbers from our denominator. Here we have an imaginary number. We have to get rid of all imaginary numbers from our denominator. The second thing we want to do is we want to make sure our result, our final answer, is in complex number form. It has to have a real component plus an imaginary component. And you'll see what I mean when we get there. But let's focus on the first part. How do we get rid of all of our imaginary numbers from our denominator? Well, we just talked about complex conjugates, right? Well, do we want to do a complex conjugate of the numerator? No. We want to do a complex conjugate of the denominator. So we're going to multiply this by 5 plus 3i. Now, we don't want to just multiply the bottom by this because that would change our question. We don't want to change our question. We want to simplify this, divide these two complex numbers without changing anything. So in order to do that, we have to multiply by 1, right? 1 is not going to change anything when you multiply it by 1. So in order to do that with multiplying our denominator by this, we have to do top and bottom by the same thing. Top and bottom by the same thing means that we're just multiplying by 1. Multiplying by 1 just changes the look, the feel, without changing the value. And that's exactly what we want to do here. We don't want to change the value, just the appearance, to something a little bit more favorable for us. This right here, us multiplying our complex conjugates in the bottom, should be all we need to get rid of our imaginary numbers. So let's multiply. Let's see what we get. So we can focus on the denominator because we know that that should be a little bit simpler. We have a 25. We already know that the middles are going to cancel out, but let's write them anyway. We have a 5, so this is plus 15i minus 15i, and we have a minus 9i squared. So that's our denominator. How about our numerator? Well, we have a 20, we have a plus 12i, we have plus 10i, we have plus 6i squared. Now that we have it like this, let's simplify everything. Well, the first thing we want to simplify is these I squareds here. Let's see what those are going to be. So we're going to rewrite everything. 20 plus 12i plus 10i. And what is this 6i squared? Now, I squared is going to be negative 1. 6 times our negative 1 means we have a minus 6. And the bottom is 25 plus 15i minus 15i, and this is going to be negative 9 times I squared, which is once again negative 9 times a negative 1, means we have a plus 9 here. So we've gotten rid of all of our I squareds. Now let's group everything into their common terms. So we have some reals, right? We have some reals, and we have some imaginaries in the top. Right, so let's simplify that. So we have 20 minus 6. That's going to be 14. And we have 12i plus 10i. Well, that's going to be a positive 22i. Now we can do the same thing for our denominator. We have some reals, and we have some imaginaries. But remember, we multiplied our denominator by our complex conjugates. Our middles should cancel out. Now, do they? Yes, because 15i minus 15i is going to be 0. So those cancel out, leaving us with 25 plus 9. And what's 25 plus 9? 34. Now, you may be tempted to leave it like this, but remember, our second thing that we want to focus on is making sure our result looks like a complex number. Does this look like a complex number? No, not in this form. Now, you can easily get this in complex number form, but this itself doesn't look like a complex number. Well, how are we going to do this? Well, let's say you had something like this. X plus y over 2, right? You know that you can do x over 2 plus y over 2. You can break this up. If you have this, you can easily get this, and you can go back and forth. It doesn't really matter. We're going to do the same thing with our complex number here. We have 14 plus 22i all over 34. Well, we're going to just break that up. 14 over 34 plus 22i over 34. 4. Now this looks a little bit closer. However, we have this 22i in our numerator. Well, you don't have to write it that way. If you have the I in the numerator, you can always rewrite this as, instead of having 22i in the numerator, you can have 22 over 34 times your I, right? 22i is the same thing as 22 times I. You can put the I on the side. Now you have something that looks like a complex number. We have a real part and we have an imaginary part. So you could end it here. However, you might notice you can go a little bit further. All of these are even. So we can simplify this. 14, 34, they're both even. So let's say we factor out or divide out that 2. Well, dividing out the 2 leaves us with a 7. Dividing out 2 here leaves us with a 17. Let's do the same thing over here. They're both even. So let's divide that 2, leave us with 11. Same 17. And we have an I here. Can we simplify this anymore? No. So this will be our true final answer. And this is still in complex number form. A real component, an imaginary component. Try not to stop here. You can go a little bit further. Let's get it looking like a complex number. We're dividing complex numbers. We want to make sure we get a complex number as a result. So I hope you were able to follow on today's video, and I hope you now know how you can divide your complex numbers. However, if you have any questions about what we saw today, or even your own homework, you can put in the comment box below, or visit my Facebook page at Tutor Me Sempai and tell me all about it there. If you hadn't done so already, make sure to leave that like. It surely helps the channel by letting YouTube know that you found the video helpful. And if you found the video helpful, so can someone else. So leave a like, hit the notification bell, smash the subscribe button, and share the video with a friend. Well, that's all the time I have for today. I'm really hoping this helped with your homework. I'm looking forward to seeing you again next week. I'm Courtney. Here's your playlist, and this has been another session of Tutor Me Sempai.